We are going to draw a curve. You already know how to draw the motion of the curve, or you already know how to draw a displacement diagram. So this is the displacement diagram which we did earlier on. So this is the displacement diagram. This is the performance. It rises up 180 according to simple harmonic. So that is how it rises. Dwell for 60. From there to there it dwell for 60. Fall for 90 degrees according to constant velocity. That is how it falls for 90 degrees according to constant velocity. From there it dwell for 30. So today we are going to focus on how to draw a curve, as we know how to draw a motion. So you extend from there to there and also from there to there. The distance from here to here, you must make sure that your pen does not touch, go on top of this one. What you can do is to take this distance, you add with this distance. This distance there, it's a stroke height, which I forgot to give it to you here. Your stroke height. I have used 40 millimeters. So meaning, to find the measurement from there to there, you can take 40, you add with the radius, with the minimum radius. Minimum radius in this case is 30, therefore it will be 40 plus 15. So make sure that this distance here is not less than 40 plus 15. So from there to there, that's your minimum radius. You take a minimum radius, you draw your center line. That distance here, I said it's your minimum radius. So from here to there, I said you take a stroke height, you add with a minimum radius. You take a stroke height, you add with a minimum radius. So that measurement, it must start here so that your cam does not touch. It must not be less than stroke height plus minimum radius. So let's carry on. What you do, you take your compass from the center, which you have just made below this line. You draw a minimum diameter. This is a minimum diameter with a radius of 15. So from there, you also draw the outside diameter. Outside diameter, you take it from the upper line there, which you have extended. From there, you take a protractor on your minimum radius center. You put your protractor, you measure 30, 60, 90, 120, 150 degrees or you use a set square if you know, or you use a radius from a compass if you know. But if you do not know, use a protractor. That will be simple. I have divided all the angles into 30 in the space of 30, as like this side it goes in the space of 30 degrees. So therefore from there here it's always 0 degrees. From there you check the rotation. In this case the rotation is anti-clockwise. Therefore your numbering must oppose the rotation. So as the rotation is anti-clockwise, meaning your numbering must be clockwise. Therefore 30 will come there. If the rotation was clockwise, therefore 30 was what's got to go there to oppose the rotation. But in this case, 30 is there, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. So, if you check between 0 and 180, that's a simple harmonic motion. If I check from this one, 0 to 180 is this side. Therefore, this side I'm supposed to write simple harmonic motion. And from 240 to 330, somewhere this side is a constant velocity. I'll write constant velocity. So now we start. If you check this side, we have 0, that side we have 0, 30, this side will also have 30. What I will do now, I will take all the angles to the other side. Here is 30, I will go up until I meet my graph line. The moment I meet my graph line, I draw a horizontal line. That's my horizontal line. Until the 0 line. So I do the same at 60, I go up until I meet the graph. When I meet the graph, I draw the horizontal line. Up until 0 run, same applies to 90. So I will do the same up until to the last angle. $180 is up there, the line is already there. $210 is up there, the line is already there. $240 is up there, the line is already there. So now I will go to $270, which is this red line. 300. Yes. 330 is down there, the line is already there. 360 is down there, the line is already there. So from there, you take your compass from the center of your minimum diameter. This line, the first line, if you take it, is the one for 30. You draw an arc up until 30. From that line, you draw an arc up until 30. Drawing this arc, you can still go clockwise or anti-clockwise, but always take the shorter distance. So this one is 60. This one here is 60. I'll draw the arc until 60. Remember to take the shorter distance. Shorter distance, not longer distance, so that your cam can be neat. And this, I have 90 there. This is 90. If you check, I've skipped this one because this is 3. So 90 is that one there. The one which I've skipped is 300, and I'm not yet on 300. 150. 150 is this one here until 150. I have skipped 120. 120 is that one there. Here is 120. Yes. So 180, it goes up there. That is 180. It means I will open up until 180. I draw up until 180, but because there's still already a line, I can just make a dot because that line it also passes. Same applies to 210. 210, I will open and I take a shorter distance. Still, there's also a line. I will just make a mark. From there, I have 240 as well. It means that's the mark. Then I go to 270. 270. 270 is that one. This is 270. I will take a shorter distance. So the shorter distance is this one to 270. This is the shorter distance. Drawing the shorter arc. Then 300. 300 is this line here. I will draw an arc up until 300. Then from 300 is 330. If you check, 330 is this line, the zero line here. Then I will draw up until zero line. The line is already there. Therefore, there it is. Then 0 is that one. 0 in 0. Remember there is 0. This is 0 line. It goes there. And 0 degrees is that one. So from there, we can now draw our curve by joining all these ends using a flexi curve. I do not have a flexi curve for the board. That is why I'm using a free hand. So from there, it will go on top there. There's no need for me to draw because the line is already there. So from there, it joins point to point, point to point, point to point, point to point. Back, if you can check here, this is the drilling at the minimum. If you check here, this is where the drilling happens at the max line. So this is your curve. So after that, you must also indicate the direction of motion This direction of motion you must indicate inside the can. So the motion is anti-clockwise, therefore we must indicate that the motion is anti-clockwise. That is the motion, the direction of motion. From there, what is remaining, we did not draw a shaft diameter which is 20, so we should draw that shaft diameter of 20. In the middle here, you will measure the radius of 10, and then you draw that shaft diameter. So, if it's a shaft diameter, you must section your shaft diameter. But if it's a whole diameter, you do not need to section a whole diameter. So this is your can. That is your can. This is your can. This is displacement motion. If you do not understand how to draw a displacement motion, you can go back to my channel. You will find where I have showing how to draw a displacement. You will have 3 different types of them. You will find them there.